Section 1.8 is about applications and problem solving, and so here we're solving applied problems involving addition, subtraction, multiplication, and division of whole numbers. And so there are 5 general steps for problem solving. And number 1 is to familiarize yourself with the problem situation. That seems natural, but that turns out to be the most important step. Then we translate the problem, typically in the English language, into an equation using a variable. So that's probably something new. And then we're solving the equation. That's why we had the previous section, how to solve equations. And then we check to see whether your possible solution actually fits the problem situation and is really a solution of the problem. And then number 5, we need to state the answer clearly using a complete sentence and appropriate units. Okay, so these are the 5 general steps, and we'll be using them in several applications in just a moment here. But the most important step is this, the familiarize step number 1. So, if the problem is presented in words, and it usually is, read and reread it carefully until you understand what you're being asked to find. Now that seems pretty obvious, but in reality that is a really, really important part. And how often should you read the problem statement? Well, until you understand it. So here's the point. Sometimes you have to read it more than once, or maybe more than twice, or 3 or 4 times. And that is just the nature of the thing. Sometimes I have to read a problem a couple of times before I understand what the actual question is. So, what I can recommend is that if you solve problems on paper, then highlight the question so that you know exactly what you're asked to find. So make a drawing, if it makes sense to do so, and write a list of known facts and a list of what you wish to find out. Then assign a letter or variable to the unknown and indicate what that stands for. Then organize the information, if possible, in a chart or a table. And then find further information, look up a formula, consult a reference book on an expert in the field, or do research on the internet, and then guess or estimate the answer, and then check your guess or your estimate. Okay? But again, step number 1 is the most important one, that you really understand the problem. So let's see how this looks like in an actual example. So here's a reading assignment. William has been assigned 234 pages of reading for his history class. He has read 86 pages. How many more pages does he have to read? So the question is, how many more pages does he have to read? Seems pretty obvious. So let's familiarize ourselves with the problem, and so let P be the number of pages William still has to read. That seems a normal way of doing things, but this creates clarity in your mind what you need to do. Translate pages already read plus the number of pages to read is equal to the total number of pages. So this is now the important step where you translate the English language problem statement into a mathematical statement. So number 2 is kind of a key to this, other than understanding what it's all about. So we are told he's already read 86 pages. He has P more pages to read, and all that has to equal the total number of pages. Well, we know the total number of pages was 234. So then we can say that 86 plus P equals 234. So here we have now an equation, and from what we learned in the previous section, we now subtract 86 on both sides. So 86 plus P minus 86 equals 234 minus 86. So then P equals 148. Now we check our answer. So if William reads 148 more pages, he will have read a total of 86 plus 148, or 234 pages. State the statement now in number 5, a complete sentence. William has 148 more pages to read. So here are the units, 148 more pages to read, and here's the number. So let's apply this to the next problem statement here. Total cost of gas grills. What is the total cost of 14 gas grills, each with 520 square inches of total cooking surface, if each one costs $398? Okay, so we can make a little drawing if you want to, but let's say this is a gas grill, another gas grill. So we have a total of 14 gas grills. And let's say that C is a cost of 14 gas grills. And by the way, the surface 520 square inches of total cooking surface is irrelevant to the question. That's just that has no bearing on the problem itself, because we asked about the total cost. So number 2, we translate this into a mathematical statement. So we have 14 gas grills times the cost of each gas grill, and the cost of each gas grill is $398. So we translate this into 14 times $398 equals the total cost. Now we multiply 14 times $398, and whether we use a calculator or multiply it, we learned it in the previous section. That is equal to 5,572. Missing a 5 here. 5,572. That's dollars. So we check by approximating the calculations. So we say, well, 14 times, it's about $400. That would be 56. It's about $5,600. So in other words, this answer makes sense. So we now state the total cost. Of 14 gas grills is $5,572. Number 6 asks the following: bed sheets. The dimensions of a flat sheet for queen-size bed are 90 inches by 102 inches. What is the area of the sheet? So we can familiarize ourselves by drawing a little picture here of a rectangle, because we are told it's a rectangular sheet. So the length is 90 by 102 inches, and the width is 90 inches. Now we know that the length is 102 and the width is 90. We know that the area is equal to length times the width. So in this case, it would be equal to, well, that would be the translation for the area that we need to determine. And so we solve this now by writing A, the area, is equal to 102 times 90. And so we can check the answer. And notice since it's 102 inches, and by 9 times 90 inches, the answer is in square inches. So we check this by saying, okay, by approximating this statement here, A is approximately equal to 100 times 90, or 9,000 square inches. And that's approximately equal to 9,180 square inches. So then we state the answer, the area of the sheet. Is 9,180 square inches. Again, the unit is important because a number without a unit of measure in an application like this has no meaning at all, because it could be square centimeters or square meters or square feet. So a lot of different units of measure are possible, but since we started out with inches and we multiply these numbers, we're going to wind up with square inches. So the unit of measure is in many cases just as important as the number itself. Always remember that in application problems. To begin with, let G be the number of gallons of gasoline used to drive 2,686 miles of highway driving. So in other words, with every gallon we can drive 34 miles. 34 plus 34 plus 34. And this whole distance then would be 2,686 miles of highway driving. So in other words, when we translate this, 34 would be the number of gallons, number of miles per gallon, number of miles per gallon, times the number of gallons used, number of gallons used for highway driving. That was G, and that has to equal the number of miles driven, which is 2,686. 2,686. So we get 34 miles to the gallon, and we multiply this by the number of gallons used, and that has to equal 2,686 miles driven. So this is the number of miles driven. And as we learned in the previous section, to solve for G, the equation 34G, 34 times G equals 2,686. We divide both sides by 34. So then G is equal to 2,686 divided by 34. Which is equal to 79. 79 gallons. And then to check our answer, we multiply 34 times 79. And we do maybe rough mental calculations. We can round this up to 80 and round this down to 30. So 80 times 30 is 2,400, which is not exactly 2,600, but close enough. So if we do the exact calculation, we find that is indeed equal to 2,686 miles driven. And so the answer checks. So then we state our answer. The 2017. So the answer checks. And so we can state now the 2017 Honda Accord Sports will use 79 gallons of gasoline and 2,686 miles of highway driving. So here's a guided solution example. To lose 1 pound, you must burn about 3,500 calories in excess of what you already burn during your regular daily activities. So to burn 100 calories while swimming, you must swim for 2 minutes at a brisk pace. So here's an important part of the puzzle. By swimming for 2 minutes at a brisk pace, you burn 100 calories. So now the question is, determine how long an individual must swim at a brisk pace in order to lose 1 pound. Okay, so that's the question. How long, how many minutes or how many hours would an individual have to swim at a brisk pace in order to lose 1 pound? So let's familiarize ourselves with the problem here. So let x be the number of hundreds in 3,500, and then that t be the time it takes to lose 1 pound. So that's the most important thing. That's what we're looking for. The x is an in-between step. So first of all, 100 times x has to equal 3,500 because we're going to burn 3,500 calories to lose 1 extra pound. So then x times 35 would be the time required to lose 1 pound. So x from this equation here, we divide by 100 on both sides, so x equals 35. And x times 2, the 2 minutes to lose 100 calories. So we multiply x times 2, or 35 times 2, and that would be 70. 35 times 2 is 70. And since 7 divided by 2 are 35, there are 35 groups of 2 minutes in 70 minutes. Therefore, you will burn 35 times 100, or 3,500 calories. So that checks. So now we state our solution here. So you must swim for 70 minutes, or 1 hour and 10 minutes, in order to lose 1 pound. So you may want to go over this again so that it all makes sense to you. But this is a very good breakdown when you have an in-between step. For example, here to determine how many parts of 35s there are in how many hundreds are in 3500. So we write it as this equation here: 100 times x equals 3500. That tells us how many hundreds are in 3500. So that finishes this example here, the guided solution. It's also in the book on page 61. The next part is really quite important, and that is how we translate the English language into mathematical symbols. For example, for addition, there are many different words. We can say to add or added to. The word sum could come up, or total, plus, more than, or increased by. All of this refers to addition. Okay, so it's about 6-7 different ways to phrase that. Similarly, subtraction can express in different ways also. Obviously, one word would be to subtract, but it could also be subtracted from, the difference, minus, less than, decreased by, take away, how many more. So these words all refer to subtraction. Then for multiplication are different words also. To multiply is the most obvious one, but multiplied by would of course mean the same thing, but product also implies multiplication. Times implies multiplication. Of, not so obvious, but the word of can also mean multiplication. Repeated addition, of course, we know represents multiplication. And rectangular arrays implies multiplication. It's not used all that often, but that also implies multiplication. And then division can be phrased in different ways as well. To divide, again, is the most obvious one, or divided by, that's pretty obvious. But the word quotient may be a new one for you. We've used it before in the previous section. But anyway, the quotient refers to a division. Repeated subtraction can also be interpreted as division. Missing factor could be or is division. And finding equal quantities. This is not so obvious at all, but that also refers to division. Anyway, so you need to study these words and how they relate to each one of these operations: addition, subtraction, multiplication, and division. And that by knowing these words in the translation makes it a lot easier to put a word problem in form of a mathematical statement, like an equation in most cases. And then there's some problem-solving tips. And so when solving problems, look for patterns, which sometimes reveal a method for solving the problem. And when translating mathematics, consider dimensions of variables and constants in the equations. The variables that represent lengths should all be in the same unit. Those that represent money should all be in dollars and not all in cents, or all in cents, and so on. So when we're working with dimensions, length, width, currency values, and so on, we have to be sure they're all consistent. And then number 3, make sure that units appear in the answer whenever appropriate. And in word problems, it's almost always appropriate to have units. There are very few exceptions. There are some, but generally ask yourself, is a unit required so that my answer makes sense? And that you completely answer the original problem. So here's another example on units. We all know there are 60 minutes in an hour, and we know there are 24 hours in a day. So the question is, how many minutes are there in a day? So when we write this, we can write this as 60 minutes per hour, and there are 24 hours per day. So when we multiply these together, then we can see that the hours cancel, and we get 1,440 minutes per day. And this concludes section 1.8.